This is AQA GCSE Chemistry. It is a dual award and therefore also triple award topic. We're looking at bonding, and this is part 3 where we're going to continue to review ionic bonding. As always, I'm going to recommend you pause on each activity, have a go at them before you review your answers. That way you get to see your own progress. So let's jump straight in with a couple of tasks. Here, on the previous video, we looked at sodium chloride and lithium fluoride being formed. In these cases, what's going to happen with magnesium and oxygen and calcium and chlorine? If you're unsure what to do, I'm going to recommend you go back to the previous video to get some ideas. But let's take a look at the example, magnesium and oxygen. I'm going to draw out the electron configurations, magnesium 282 and oxygen 26. Now that means magnesium wants to lose 2 electrons to get a full outer shell. Oxygen wants to gain 2 electrons to get a full outer shell. Well, that works out quite well. Magnesium gives both of its outer electrons to oxygen, and that then means that we have formed some slightly different structures. Magnesium, instead of being 282, is now 28, and oxygen, instead of being 26, is now 28. They've got full outer shells. But they've also got charges. If magnesium has lost 2 electrons, it means it has a charge of +2, and if oxygen has gained 2 electrons, it means the oxide ion has a charge of -2. So now have a go at calcium and chlorine. Well, if I draw them out, I've got calcium here, which is 2882, and I'm going to draw a chlorine atom just down here, which is 287. I can see here that calcium has 2 electrons it wants to give away, and chlorine can accept 1 more to get a full outer shell. So that's fine for the chlorine, but it doesn't help us manage what's going to happen to this. If it's calcium and chlorine reacting to make calcium chloride, I need another chlorine, and this electron can go to that chlorine. Now that then means that I've got 1 calcium ion, I've lost 2 electrons, so that's +2. Each of my chloride ions have been formed after gaining 1 electron, which makes them -1, but there are 2 of them. And we can also then see that the formula is CaCl2. For this task, a little bit of a review of older work. What do we mean by these key terms? And we can say that an element is made of only 1 type of atom. A compound is made of more than 1 type of atom that is chemically combined. And a mixture is made up of more than 1 type of substance, and that is not chemically combined. So the substance, you can have a mixture of compounds and elements. Think about the air, which is a mixture of argon, of molecules of oxygen, and molecules of the compound carbon dioxide, but they're not chemically combined together. Okay, a little bit of work here on noble gases for you to think about. So writing out the electron configurations, we can see that helium with 2 electrons is 2, neon with 10 electrons is 28, and argon with 18 electrons is 288. So why would they not be reactive? Well, we've spoken at length about the fact that atoms lose or gain electrons when they react to get a full outer shell. These already have a full outer shell, and for that reason, they don't need to lose or gain any electrons to achieve it. So they don't react. They simply don't have a need to. Going to move on to ionic formulae, and there's a lot to think about here. And it is definitely worth, when we get to the table in a couple of moments, actually jotting it down and having a go at it for yourself. You are going to need to remember each of these charges. You're going to have to learn them for the GCSE course, but actually lots of them we already know about. We know that group 1 form +1 ions. We know that group 7 form -1 ions, group 6 -2, group 3 +3. We don't have any group 2 on here, but they would be +2. If you remember those simple rules, you have far less to remember. So I'm going to recommend you either watch one example and then have a go at the rest, or just have a go at these and then review your answers. So we're going to start off on the top left hand corner. I'm going to draw out a seesaw to show you exactly how we can visualise the answer. I put my positive ion on the left, my negative ion on the right, and that will always be the case. I'm then going to put the charges on top of my seesaw. So lithium has a charge of +1 and fluoride has a charge of -1. To balance my seesaw, I need it to come to 0 overall. I need the magnitude on each side to be equal. Well, in this case it is. I've got one lithium with a charge of +1 and I've got one fluoride with a charge of -1. So the formula is LiF. And I can do exactly the same thing with NaF using the same principle. I can do the same thing with LiCl. I can do the same thing with NaCl. It also works with LiBr and it works with NaBr. All of them, +1, -1, you have one of each to balance out. Let's now complicate it a little and let's look at lithium and oxygen. So I know that lithium has a charge of +1, but I know that oxide has a charge of -2. I need to balance my charges out. All I can do is add more lithiums or more oxides. Well, in this case, if I've got -2 on the right and I want +2 on the left, I simply add another lithium +1. 2 lithiums, so the formula becomes Li2, remember it's always a small number within the molecule, Li2O. And if I look, I can use exactly the same process to get to Li2S. I can do the same to get Na2O, and it works in the same way to do Na2S as well. Now let's have a look at another different example. Let's do magnesium and fluoride. So in this case, we know that magnesium is +2 and we know that fluoride is -1. Well, I need two -1s to counteract my +2. So I've got one magnesium and I've got 2 fluorides. My formula is MgF2. And once again, I can parallel that with my MgCl2 and my MgBr2. So let's now have a look at the next option, which is going to be Mg and O. Mg is +2, O is -2. They balance out. I don't need to add any more Mgs or any more Os. So my formula is MgO. And exactly the same process would take you to MgS. So now let's move on to this final column. We have got aluminium and fluorine. Now aluminium is +3. Fluoride is -1. To balance these out, I'm going to need 3 -1s to get to -3 to balance out the +3. So I've got 1 aluminium, I've got 3 fluorines, AlF3. That's also true for AlCl3 and it's also true for AlBr3. Now let's take a look at aluminium with oxygen. So aluminium is +3, oxygen is -2. Well, they're not balanced. This is certainly too low, I need more. So let's add another. I've now got -4 and I've got +3. This is now too low. So let's add a second aluminium. I've now got +6, I've got -4. Well, I can add another -2 now. I've got 2 aluminiums, I've got 3 oxygens. The formula is Al2O3. The other way of looking at this, once you get more confidence, is the +3 and the -2. What's the lowest common denominator of 3 and 2? And it's 6. So I need 2 +3s and 3 -2s. Exactly the same process will get you to Al2S3. So we're going to continue and we're going to take a look at what happens when these get a little bit more complicated. I'm going to talk you through the example of magnesium sulfate. Magnesium is on the left because it's the positive ion, sulfate is on the right because it's the negative ion, and the charges were provided in the table at the start of this. As I've said, you will need to learn them. Magnesium is +2 and sulfate is -2. It's already balanced. I don't need multiple Mgs, I don't need multiple SO4s, so I have MgSO4. And you will notice I have not changed the structure of the SO4 ion at all. It stays as SO4. Now let's take a look at this example before we go on to the next table. Now in this one, we have got 1 magnesium plus 2, and we've got 2 OHs minus 1. However, this does not show 2 OHs. It shows that I've got 1 Mg, 1 O, and 2 H's, because the 2 comes after the H only. How could we adapt this? How could we add something to this to show that there are 2 OHs, not just H's? Well, if I write the formula out below, the way we do it is where we have a complex ion made up of more than one atom. If there are multiple of them, we put them in brackets. With that in mind, let's have a go at completing this table. I'm going to start off with the lithium column first, actually, because that's more straightforward. Li and Cl. Well, Li is plus 1, Cl is minus 1. I need one of each of them, so my formula is LiCl. If I move across to lithium hydroxide, I have an Li and I have an OH. Lithium is plus 1, OH is minus 1. And that means I've got one of each of them again. So I take my Li and I put my OH after it. Remember, it's capital O, capital H, because it's an oxygen and a hydrogen. I've got LiOH as my formula. Now let's move across to lithium sulfate. So I draw out my seesaw, and sulfate is minus 2, but lithium is plus 1. So I need 2 of my lithiums and only 1 of my sulfates. So the 2 goes just after the lithium in the formula, Li2SO4. And using exactly the same process with CO3 2- instead of SO4 2-, we get to Li2CO3. Now, I'm going to move down and look at some that we can do using knowledge we already have from the previous table. Mg and Cl would give us MgCl2, and Al and Cl would give us AlCl3. So now let's move on to magnesium and Mg and OH. Well, magnesium is plus 2, hydroxide is minus 1. So I'm going to need 2 of my minus 1s to counteract and to counterbalance my plus 2. So my formula is 1 Mg and 2 OHs. Hopefully you've remembered from the example we did previously that we need the brackets MgOH2. Exactly the same thing will happen if we do aluminium at plus 3. I'd need 3 OHs, and that becomes AlOH3. So now let's take a look at magnesium sulfate. Magnesium is plus 2, sulfate is minus 2. I've got one of each of them. I'm not going to change my structure of the SO4, MgSO4. And exactly the same process will take us to MgCO3. Now let's consider aluminium with sulfate. Now we saw with aluminium oxide plus 3 and minus 2 that we are going to get multiple on both sides. Here I need 2 aluminiums at plus 3 each and 3 sulfates at minus 2 each. So that's Al2SO4 3. But as I read that, that looks like Al2SO43. Here's an example where we need brackets. Brackets around the SO4 now tells us we have 3 of the SO4. And we're going to move on. Same thing will happen with aluminium carbonate, Al2CO3 3. And now let's go to this top line. I take my NH4 and my Cl. I've got one of each of them. I'm simply going to put my positive ion, then my negative ion. I'm not going to change the structure, NH4Cl. Exactly the same thing happens if I do NH4 with OH, plus 1, minus 1, one of each. The formula is NH4OH. If I'm going to do this with NH4 and SO4, SO4 is minus 2, but NH4 is plus 1, so I need 2 of the NH4s. Now, again, I need the brackets, otherwise it would say NH42SO4. The brackets tell me I've got 2 of the NH4s because I need 2 of the NH4s. And then from there, same situation when we get to NH42CO3. To finish off what is quite a lengthy video, a little bit more to consider here about the formula of each of the examples. It's important that you recognise that if we have Roman numerals, it's because the metal can have more than one charge. And the Roman numeral is going to be the value of the charge. Because it's a metal, it will always be positive. Have a go at it, see how you do. So in the first example, I've got Cu and O. My Cu is +1, my O is -2 from the table, and because it's group 6. I need 2 coppers to counterbalance the -2, so the formula is Cu2O. However, in copper 2 oxide, copper is +2 and oxygen is -2, or the oxide ion is -2. That means I only need 1 of each, so copper 2 oxide would be CuO. If I take a look at iron oxide, iron 2 oxide, Fe is +2, oxide is -2, I need 1 of each of them, I have FeO. And for iron 3 oxide, I have iron at +3, oxide at -2, I need 2 of the ions, 3 of the oxides, so it becomes Fe2O3. For zinc chloride, zinc is +2, chloride is -1, provided in the table, and it's in group 7 to help you remember. I need 2 of the chlorides, so it's ZnCl2. Titanium at +4 and chloride at -1, I need 4 of the chlorides, so it's TiCl4. Vanadium 4 oxide, if vanadium is +4 and oxygen is -2, I need 2 of the oxygens, so it becomes VO2. And if I look at vanadium 5 oxide, vanadium is +5, oxygen or oxide is -2. Lowest common denominator here is 10, so I need 2 + 5s, 5 - 2s, and it comes to V2O5. That takes us to the end of this video. Thank you for listening, and goodbye.